Hello, we are discussing about GATE 1991 ECE paper, and this is one more question related to electronics. Look at the diagram. The diode can be able to connect it to plus 20 volts or minus 20 volts. Referring to the figure, the switch is in position 1 initially and steady state conditions exist from time t is equal to 0 to time t is equal to t naught. The switch is suddenly thrown into position 2 at t is equal to t naught. The current I flowing through the 10 kilo ohm resistor as a function of time from t is equal to 0 is. So how the current changes from t is equal to 0 to t is equal to infinite. Okay, whenever the switch has changed from plus 20 volts to minus 20 volts, that is position 1 to position 2 at t is equal to t naught, you are going to draw the sketch for the current with respect to time axis. Okay, we will see what happens, how to draw this one. Next, this is a diagram given. Okay, and this is initially, that is from t is equal to t naught. We are going with a case 1 when time is in between, okay, t naught and between 0, that is whenever the time is in between t is equal to 0 to t naught. T naught is nothing but we are going with t naught minus, specifically just before t naught. At that time diode is connected with plus 20 volts as the diagram shows, so that diode is forward biased. Whenever the diode is forward biased, acts as short circuit. So current flowing through the diode is nothing but 20 volts divided by 10 kilo ohms, which is nothing but 2 milliamperes. 2 milliamperes. Now this much is the current flowing through the diode from current I. I flows from P to N. Remember that one. So this is the direction of current under case A. Okay, but the switch is going to be suddenly changed from t to t naught. That is at t is equal to t naught, switch is suddenly changed from position 1 to position 2. Okay, so this is the situation we are getting. This is the situation. The switch is changed to position 2. Whenever the switch is position 2, at that time, this is we are going with case B with a different color. Okay, now for t is equal to t naught minus, switch is at position 2. Switch is at position 2. By that time diode is connected with negative voltage, so diode becomes reverse bias. Even though, that is, diode becomes reverse bias, now the current should flow from P to, that is N to P. Current flows from N to P. So the direction of current is this one. This is the direction of current, N to P. So if you observe at t is equal to t naught minus, and this is t naught plus, sorry, this is at t is equal to t naught plus, that is after application of switch, just before application of switch change. So at t is equal to t naught minus, diode is forward bias and current flowing is 2 milliamperes, that too from P to N. Whenever at t is equal to t naught plus, switch is changed to position 2. By that time you are applying minus 20 volts, which makes the diode reverse bias. Okay, so at that time what we are expecting is current should flow from N to P, and under reverse bias the current is nothing but I naught. But at the instantaneously the diode is going to change the currents. It doesn't change the currents instantaneously. Remember that one. So when the diode is instantaneously switched from a conduction state to non-conduction state, it requires some time to return back to the non-conducting state, and during that time it behaves as short circuit even though it is in reverse bias. This is due to accumulation of stored excess minority carrier charge when the diode was forward bias. So the time required to return back to the state of non-conduction, that is full reverse bias, is called as reverse recovery time, which is sum of storage time and transition time. So it requires some time, that is reverse recovery time. TRR is nothing but sum of storage time plus transition time, TT. Okay, so in this case we can go like this. First case, whenever the time is in between T0 plus to Ts. Okay, so during this time diode, even though it is reverse bias, but act as short circuit, so that whenever it is acting as short circuit, the current flowing through the diode is nothing but minus 20 volts divided by 10 kilo ohms. So the current is minus 2 milliamperes. And second case, whenever it is between Ts2, the time is in between TRR, that is below reverse recovery time, but it is greater than storage time. So by that time current starts reducing to I0 exponentially. Current reduces exponentially from 2 milliamperes, minus 2 milliamperes towards I0, and at T is equal to TRR, at the reverse recovery time, the current reaches I0 itself. This is the reverse time, reverse saturation current. That is the actually expected current under reverse bias. So we can draw a graph based on these equations. Okay, the sketch is asked in the question. So we'll go with different colors for the sketch. So this is y-axis and it is x-axis. X-axis is time axis starting from t is equal to 0 and where the switch is changed at t0, and after that one we will get the storage time, and after that one it is TRR, reverse recovery time, which is nothing but sum of Ts plus Tt, storage time and transition time. Okay, so during 0 to T0 the diode is under steady state with forward bias, so that current is 2 milliamperes. Current is 2 milliamperes at this time. So diode is forward biased with 2 milliamperes, and at t is equal to T0, switch is suddenly changed. So it has changed to minus 2 milliamperes, till storage time is completed. So this is minus 2 milliamperes, and till the storage time reaches it will be at minus 2 milliamperes only. From this point onwards transition time starts, that is at the end of storage time transition time starts. During transition time this is going to be starts reducing exponentially, and at the end of storage time, that is nothing but at t is equal to TRR, it reaches the value as I0. You can think in this way. This is I0. So from this one the current is nothing but I0. Sorry, this is okay. So from this one the current reduces exponentially and it reaches I naught. Okay, it will be drawn like this, a little bit confusing. Remove this one. Okay, now the current is reducing towards this one I naught, and this current is nothing but now it is I naught. This is a sketch. Okay, T naught, Ts, Ts plus Tt, that is TRR. So current reduces to I naught. We can check diode. During this one diode is reverse bias but act as short circuit, so that you will get minus 2 amperes. And during this time diode is exponentially reducing, and after that one it has reached the steady state of I naught. So this is the diagram required. Thank you.